Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now. Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello. Yeah, I suppose now I am audible. Dinesh, hello Naikaj, hello Hitesh, can you please confirm? Okay then. So let me share my screen and then we will start. So, Naikaj, I did not observe you. You were not attending the last few sessions, I suppose. So, how are things going, Naikaj? Okay, Dinesh, thank you very much. Yeah, so before we start, let me give you a small introduction about the series that we are presently having. Okay, so this particular series is called Practice Session for SDE Interviews, and today the topic we will be discussing is graphs and trees. And today and tomorrow will be the last. Tomorrow will be the last session for this particular series, and from after that we will be having another series from the month of May. Okay, so details about that I haven't decided yet, and I will let you know. Apart from that, yeah. So there is a course called Complete Interview Preparation on the GFG platform itself. You can definitely check that out if you're preparing for your interviews. That is an extremely well structured course for your interview preparations. Okay. So last week we discussed about dynamic programming, and we discussed quite a lot of concepts on dynamic programming. So today and tomorrow we will be devoting majorly to graphs and trees. Okay. So yeah, I would request all of you all to kindly stay in this session till the very end, and then we can discuss a few important questions. Okay. So before we proceed, yeah. So I told you about the course called Complete Interview Preparation. You can check out the link in the description. Okay. So how many of you are in your second years or you're in your third year right now, and you will be having your upcoming interview? Like after 3 4 months maybe, like in the month of August and September. I suppose that is the interview plan placement season for majority of the campuses in India. Dinesh, what about you? Hello Shriyansh. Hello Hitesh, what about you? So this particular yeah, so this is an extremely well structured course for your that will certainly help you in your interview preparations. Okay. And yes, so also those who have joined with me presently, can you please do a +1 in the chat box so that I could get to know your names? I'm actually a master student and I have one semester left. Okay, Hitesh, I am finally year 2023 passed out. Oh, okay, okay. That's great, Dinesh. So, Dinesh, will you be starting a full-time employment after your graduation? Okay. Okay. Since you need help with trees, so are you a complete beginner in trees, or do you already have the required concepts? Okay. So for those who are entirely beginner, the at Geeks for Geeks you will also find a course called self-paced course. Okay. So this is a self-paced course. So DS is self-paced course. Starting from the basics of C++ till segment tree and other advanced concepts, this entire course basically is a very comprehensive course in itself. Okay, and things are explained in a very lucid manner if you are studying this particular course. In fact, when I started with my preparation journey, I also started with this particular course, and I covered majority of the topics from this particular course. Okay, in fact, when you read something online, and you will definitely not be able to understand things, but in this particular course, things are explained so lucidly that things become very clear, all the important algorithms and concepts. Okay, so definitely check both of these courses out. They are very certainly be helpful to you all. Complete interview course is called the CIP course, and this is the DSA self-paced course, DSA SP course. Okay, so you will also find problems and other important concepts related to the DSA self-paced course. Okay. So it's a complete course in itself. Okay, then before we proceed, please do a +1 in the chat box. I would really love to know your names. So let me give you a small introduction about myself before I proceed with the concepts of graphs and trees today. Okay, so my name is Gaurav Kumar Shaw. Okay, you can look me up on LinkedIn by the same name. Okay, in fact, if you want, I can give my LinkedIn profile link as well on the chat box. And I am presently in my third year. In fact, the third year is about to end at IIT Kharagpur. Okay, and I have been a mentor at Geeks for the past 7 8 months, and I'm also a SDE intern at CureFit. So this is a brief introduction about me. You can definitely, if you would like to get connected with me, you can search this particular name on LinkedIn, and you can connect with me there. Okay, so let's start with the topics of graphs. So, can anyone tell me? Hmm, today we will be taking up few important concepts related to graph. The first would be, let's say, connected components. Okay. So, do you all know what exactly are connected components in a graph? Any ideas, anyone? Hello, Hitesh. Hello, Dinesh. Hello, Naikaj. Hello, Shriyash. I would request all of you all to kindly keep the interaction in the comment section going on, because that will most certainly be helpful for me and at the same time for you as well. Yeah, so can anyone tell me? Okay, connected edges. One node is linked to the next, and one view of the trees. Okay, so basically everyone knows that in graphs we have vertices. Okay, and for example, this is a vertex 1, 2, 3, and 4, and let's say connect 1 and 2 together and 1 and 4 together, and 3 is not connected to any of the edges. Or in fact, let's say I have 5 together and I connect 3 and 5 together. Okay, so what will basically happen here? Hmm. So what will basically happen here is that so 1 to 4 and 3 and 5. So what will happen is that the number of connected components in this will be is equal to 2. Why it is equal to 2? Because you see that 1, 2, and 4 belong to one component, and 3 and 5 belong to one component. So this component is not entirely connected to this particular component. Okay. So the question would be that you're given a graph, okay, in the form of an adjacency list or a matrix. Okay. So now your task is to find the total number of connected components. Total number of connected components. How will you do this? Yeah. So how will you do this? Total number of connected components. Anyone? Can anyone tell me how will you do this? Total number of connected components. Okay, yes, DFS. Can you give a small idea about how exactly? Number of time DFS is called. Yes, exactly. So let us say we do something like this. For example, everyone knows about how exactly a DFS codes work. Okay. So let me write a small code for DFS. In DFS, what happens is that we write a DFS. We send the vertex to our DFS. Okay. So so we send our vertex and we also send the parent. Okay. So now what happens is that we iterate across all the child of our parent. Okay. Auto IT into G of vertex. And then we put a check condition that if IT is equal to the parent, okay, in that case we just continue. Okay, because we don't want to call the DFS for the parent. Okay, but we want to call the DFS for the child of the graphs, or the child of a particular edge. And so in this case, this particular IT, which is equal to the child, so IT, okay, so this IT, which is equal to child, becomes the vertex, and the vertex becomes the parent. Okay, we call it DFS. Okay, so this particular is a concept of DFS, but in this concept, we are just skipping up the parent part if it is already not visited. Okay, but we can also keep track of the same thing using a visited array as well. So we declare a visited array, and every time we are visiting into the DFS, we are just marking the DFS is equal to 1. Okay, which means that I have already visited the array. And if visited is already true, in that case, I will not visit the particular array. Okay, so what will I do here is that instead of writing this, okay, I can simply write this, that if visited of child ID is not equal to true, then only proceed this. Okay, or if it is equal to true, that means that I have already visited the child. Okay, if it is equal to true, in that case you can just continue. Okay, and otherwise you can write DFS of IT or vertex, right? So this is the DFS code. Okay, so let's do a small dry run of this particular code here. So let's say I give you a vertex 1, 2, 3, and this is 4, and this is 5. Okay, and this is 6. Okay, 4 and 5 are connected to each other. And I ask you to call a DFS for 1 comma. Let's say I just ask you to call a DFS for 1. Okay, so we don't need a parent array right now here. Okay, so because we are already having a visited array, so we don't need a parent array. Okay, so yeah. So let's say I call DFS for 1. So what will happen? First of all, I have a visited array. So this is my visited array, 1, 2, 3, 4, 5, and 6. So initially 1 will be marked as visited, and then it will go to the child of 1, which is 2. So it will so 1 will try to go to its child 2. Okay. So auto IT geo vertex 1. Now 2, once it will go to 2, it will again DFS for 2. 2 will also mark visited. Now 2 will it will try to go to its child of 2. So the child of 2 would be 3, 6, and 1. Okay, because there is a direct edge connected from the vertex number 2 to 3, 4, and 6. But we have already visited 1, so we will not go for 1. We will instead go for 3 and 6. So 3 will be marked visited and 6 will also be marked visited in one DFS call. But these two particular nodes, 4 and 5, are not yet visited just because of one DFS call. Okay. So what do you think will be the solution for this case? Can anyone give a slight small explanation about this? Hmm. Yes, runtime error, you are correct that the number of DFS calls we are presently having will decide the number of connected components that we have. Okay. So what we will do basically here is that, let's see. So what we can do is that we will just try to call this thing. Hmm. For example, let's say I will run a loop for int I is equal to 1 to I is equal to n. It means that there are n edges. And I will check whether visited of I is equal to true or not. If it is not equal to true, it means that it has not been visited. So I will call a DFS for I. Okay. And I will also do a count plus plus. Okay, why I am doing a count plus plus? It is basically because I want to count the number of connected components. So initially, for every time one particular connected component goes, it will mark all the nodes in that component as visited. Okay, so a DFS call will mark all the nodes, all the nodes in that connected component add as visited. Okay, so all the nodes in that connected component will be marked as visited. So every time a DFS call is being made, it means that it is for a one particular connected component entirely. So that is the reason I am doing a count plus plus. So in this case, this count variable will be updated to 2, and only 2 times DFS call is being made. Okay. So this is the reason the value of count will be 2. Okay. So yes, Dinesh, yes, runtime error, you are all correct, correct, correct. So can I please have a plus one in the chat box if you all understood this concept? Just to do a plus one in the chat box. Hello Nikaj, hello Hitesh, hello Dinesh, hello runtime error. So runtime error, what's your real name? Because it sounds really funny if I try keep calling you runtime error. In fact, having a runtime error in your code is one of the scariest things after logical error, I suppose. So can I please have a plus one in the chat box if you have properly understood the concept? That's great. Okay, yeah. So yeah, now let us look into another concept of diameter of tree. So does anyone know what exactly the diameter of a tree and how we can find that? Hmm. So do you know about the diameter of a tree, Dinesh? Hello Hitesh, hello Dinesh. Okay, yeah. So let me just give you a small example about what exactly is the diameter of a tree. Okay, yeah. So, so let me give you a small example of what exactly is the diameter of a tree. Okay, so for example, let's say this is a tree. One, two, three, 4, 5, 6, 7, and 8. Okay, so from the node number 6 to node number 8, you can see that this is the longest path of the tree. Okay, from 6 to 4, 4 to 2, 2 to 1, 3, 7, and 8. So basically, this entire path is called the diameter of a tree, and the length would be 1, 2, 3, 4, 5, 6, 7. Okay, so diameter of the tree would be 7, or in fact, you can say number of edges 1, 2, 3, 4, 5, 6, or the number of edges is equal to 6, or all 7 vertices are there, and the number of edges is equal to 6. So this is the diameter of a tree. And the question is that you're given a tree and you're asked to find the length of the diameter of a tree. Okay. So how will you do that? Okay. So does anyone have any idea how you will do that? Any idea, anyone, how you can solve this question and find the diameter of a tree? Anyone, you can write any ideas you have in the chat box. I would really appreciate it. Hello Dinesh, hello Naikas, are you here? Hello Hitesh, hello Runtime. So if you have any idea, you can write that. How can we just think of like what algorithms can you apply and what concept you will use so that you can get a diameter of a tree? Okay, and let me know.